Welcome back, students. So we will discuss one more example based on Green's theorem. In the last class we have verified the Green's theorem. What is the Green's theorem? Here it is. Integration of m dx plus n dy is equal to double integration over the region R into dou n by dou x minus dou m by dou y into dx dy. And look at what we are going to verify. Verify the Green's theorem for this function. Integration over a closed curve. Integration over a, if you write a circle, it stands for the curve is closed, not open. Okay. Over a curve, see xy plus y square into dx plus x square dy. Where what is the curve? Curve is a sum of a straight line and parabola. Curve is a what? Sum of straight line. Y is equal to x is called a straight line passing through the origin. This is y is equal to x square. Y is equal to x square is the parabola open above the x axis. Let us draw it later. Okay. And we need to verify the Green's theorem. We know the Green's theorem very well. And compare this given equation with m dx plus n dy. Dx coefficient is m, that is xy plus y square. And coefficient of dy is n. What is the value of n? N is x square. So let us find out dou n by dou x and dou m by dou y. They are the partial derivatives. Partial derivative of n with respect to x and m with respect to y. M with respect to y, differentiate with respect to y. It's a product of two terms. Okay, with respect to y, x is a constant, take it outside. Only y remaining, differentiation of y is 1. Plus y square differentiation is 2y. Again x square differentiation is 2x. Okay, they are alone. Okay, fine. Then the difference is dou n by dou x is 2x minus x minus 2y. 2x minus x is x, x minus 2y. What is the third step? Third step is we need to form a closed curve. For that, first we can draw geometrically, right? Draw the curves. What are the curves we have? Y is equal to x and y is equal to x square, and find the what? Point of intersection. What is point of intersection means? Where they both the curves meet. Yesterday we have find the point of intersection for the parabolas. Y is equal to x square and x square. Y is equal to x square and x is equal to y square. Okay, there the point of intersection was 0, 0 and 1, 1. So let us draw this diagram and observe what will happen. So two-dimensional. First draw y is equal to x. Y is equal to x is the line which will bisect the first quadrant and third quadrant. It will exactly bisect. Bisect means it makes equal part. And what is y is equal to x square? Y is equal to x square or x square equal to y is this. So this is y is equal to x is the line. The curve is y is equal to x square. Okay. You people already know that what is left side? Left side is line integral. You need to evaluate along the boundary, right? What is the right side? Right side is the double integral, means area or it's a region. We know how to evaluate double integral, right? We have two methods we have explained already. Evaluation of double integral by changing the order of integration, by converting to polar form, and we also with respect to the given region also we have evaluated. So therefore, so first what actually we need is we are going to find out the point of intersection. To find the point of intersection, what we will do? Yesterday I have written here everything. To find the point of intersection, solve. Solve ಏನು ಮಾಡಬೇಕು? Solve y is equal to x square and y is equal to x. You need to solve these two equations. So let us substitute this y is equal to x in the first equation. What we are doing? Substitute. Please y is equal to x in y is equal to x square. Y is equal to x. Y is equal to x means x equal to x square, right? You transform x to right side, what will you get? X square minus x equal to 0, take x common, x minus 1 equal to 0. These are the two factors, x equal to 0 and x minus 1 equal to 0. X equal to 0 and x equal to, you will get 1. You will get two values of x, x values are 0 and 1. Corresponding to this, find the value of y. Substitute in this equation or in this equation. It is left to you people. I am substituting in y is equal to x. Okay. When x equal to 0, what is the value of y? Y is 0, right? When x is equal to 1, what is the value of y? X equal to 1, y value is 1. Therefore, points are what? When x is 0, y is 0. When x is 1, y is 1. Means these are the points you will get. These are called point of intersection of the curve y is equal to x and y is equal to x square. Y is equal to x and y is equal to x square. Okay, once if you find the points, next I am going to find out the line integral. Okay, to find the line integral, the curve must be what? Curve must be a what? Closed. To find the line integral, curve must be closed. Okay, I am going to express this as a, you can call it as a O and this is A. This is OA and AO. This is AO. OA completely makes a closed. OA, AO completely makes closed. Therefore, let us go for LHS. What is LHS we have? Integration over a closed curve C, m dx. What is the value of m? So write this value as it is. X y plus y square into dx plus x square dy. Now this closed curve can be splitted as, look at here, this closed curve can be splitted as OA plus AO, isn't it? OA plus AO. Therefore, this can be written as, this is along OA, right? We can write xy plus y square into dx as it is, plus x square dy plus AO, right? xy plus y square into dx plus x square y. And you people already, you know that I have substituted as a I1 and I2, isn't it? In the last example also, call it as equation number 1. Isn't it? Okay, now let us evaluate I1. What is I1? I1 is to evaluate I1. We are to evaluate I1 along. We are going along on what? Along the curve OA. Along the curve OA. Which curve we are going to consider along the curve OA? Y is equal to x square is the curve along OA. Okay. So you are substituting y is equal to x square means you need to differentiate this. What will you get? dy is equal to 2x dx. Again x varies from, just look at what is the value of x. X runs from 0 to 1. Okay. X varies from where to where? 0 to 1. So therefore, this value, I will write I1. I1 is equal to integration. X runs from where to where? 0 to 1. X into, what is the value of y? X square plus y value is x square whole square is x raised to 4 into dx as it is plus x square. What is the value of dy? 2x dx. Okay, and now which is equal to x runs from 0 to 1. This is how much? Say loudly, x raised to 3 plus x raised to 4, 2x into x square, 2x cube into dx is common in all the terms we have written, right? Okay, fine. Finally, this will become x runs from 0 to 1, x cube plus 2x cube is 3x cube plus x raised to 4 into dx. You can integrate it this. 3 is constant, integration of x cube is x raised to 4 by 4, x raised to 4 is x raised to 5 by 5 between 0 to 1. Okay, substitute the upper limit. X is 1. 3 by 4 times of 1 is 3 by 4 plus 1 by 5. This is just 1 by 5 minus lower limit 0. 0 by 4 is 0. 0 by 5 is 0. Totally lower limit is 0. You can add these two values. What is the LCM here? LCM is the 20. 5 3s are 15. 4 1s are 4. 4 5s are 20. This is 19 by 20 is the value of I1. Right. Next. Along what? Along AO. Along AO. Along AO is what? Y is equal to x. Isn't it? Along AO is y is equal to x. Again y in terms of x. Differentiate this. dy is equal to dx. And x varies from? X varies from? Reverse. We are coming reverse. X varies from 1 to 0. This is 1 to 0. Now what about I2? I2 is equal to? I2 is equal to integral runs from? X runs from 1 to 0. Look at this. X, keep it as it is. What is the value of y? X plus y square is x square into dx plus x square is as it is. This is dy, right? This is dy. Okay. What is the value of dy? Dy value is dx. Okay. Now, what is this total value? This is x into x is x square. X square plus x square is 2x square. There is one more x square. Both coefficients are dx. How many x squares? 3x squares. 3x square divided by or 3x square into dx between the limits 1 to 0. You can integrate this. Integration of 3x square is 3 into x cube by 3 between the limits 1 to 0. 3 and 3 get cancelled. Substitute upper limit 0, cube is 0, minus 1 is just minus 1. Therefore, equation number 1 becomes, what is equation number 1? LHS. Equation number I1 plus I2. What is I1 value? 19 by 20 minus 1. What is the LCM? 20. 19 minus 21s are 20. 19 minus 20 is minus 1 by 20. Okay? This is only the LHS. We will discuss the right side, that is RHS. Just you can note down it. We will discuss it. Okay, now let us verify the right side one. Okay, what is the right side, students? Right side is a double integration, isn't it? Look at the right side. The right side is RHS is equal to double integration over a closed region dou n by dou x minus dou m by dou y into dx dy. Please concentrate, you can note down later. Okay. Look at, we are evaluating a double integral. I want a region. Region means I told you already. It is a place. Region means a place. Place means not a point. It is like a two-dimensional. So this is a region, student. This is called a region, or it's also called an area. I have written already, it's an area. We need to find out this area. I told you already what Green said. The line integral is same as double integral. Line integral is same as double integral. We have verified the line integral along the border. Now we are going to find the area instead of going through the border, through the perimeter. Okay. So now, or through the circumference. So to evaluate a double integral, I want the value of x as well as y, isn't it? I want x value as well as y value. You people already aware, we want the value of x and y. I want left to right, lower to upper. Horizontal strip, vertical strip, I want to make it here. So therefore you people know dou n by dou x value is, dou n by dou x minus dou m by dou y value is x minus 2y. You write first dx or then dy, or you can write first x then y, no problem at all. This is first dy then dx. Okay. Now can you tell me what is the value of x and y here? ಹೇಳ್ಬೋದು ಯಾರಾದರೂ? Okay. Now look at the board. As we know already, I want to write, you can write in any form, either first write y, then x, doesn't matter. But you must remember that if you write first x, x takes constant limits. If you write y, y takes constant limits. This should be the thing you have to remember while evaluating a double integral. Okay. So I want to write a constant limit. Constant limits in the sense it's a number, means it is in terms of a lines. So how do you write this? I am writing in this form. What does it represent? X equal to 0. What is x equal to 0? Equation of y-axis. And similarly, I have x equal to 1 and y is equal to 1, isn't it? What is x equal to 1 means? X equal to 1 is this line. Sometimes you write while drawing the graph, right? This is x equal to 0, x equal to 1, x equal to 2, like that, isn't it? So likewise, if I write the coordinate x equal to 1 means it is the line parallel to what? Y-axis. Similarly, if I write y is equal to 1 means it is line parallel to x-axis. It is the intersection of this, like this. This is like x equal to 1, this is y is equal to 1. The point of intersection is called 1, 1. Okay, I think you people you have studied in SSLC level. X equal to 1 and y is equal to 1 is what? It's a point. A distance of this point from y-axis is 1, x-axis is 1. Okay. Now I have written x equal to 0 and x equal to 1. I think you people are already aware that. If I write x equal to 1 and y is equal to 1, what does it calculate actually? What does it calculate? If I write in this form, how this integral thinks? It thinks that it will calculate the area, it will calculate the what? Area between x equal to 0 and x equal to 1. ಇವೆರಡು ಲೈನ್ ಅದಾವಲ್ಲ, ಇವೆರಡು ಲೈನ್ ಮಧ್ಯದಾಗ ಎಷ್ಟು ಏರಿಯಾ ಬರ್ತದೆ ಅಷ್ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುತ್ತೆ. ವಾಟ್ ಆ್ಯಕ್ಚುಲಿ ಇಟ್ ವಿಲ್ ಡೂ ಈಸ್, it will calculate area between these two lines. If these two lines go infinitely, it will calculate infinite area. ये जो दो लाइन है नहीं, ये दोनों लाइन it will go indefinitely, that is infinitely in the downwards and upwards, doesn't matter, it will calculate area between these two lines. But our aim is we don't want area below this and above this. So that's what we need to restrict by using the value of y. This is 0 to 1. Okay, what is the lower? This is left to right is over. Left to right means x equal to 0 and x equal to 1. I want lower portion means lower. What is lower? What is lower? What is lower? Say loudly, what is lower? Y is equal to x square. This lower portion is what? Y is equal to x square. What is the upper portion? Y is equal to x. Enough. You have assigned the limiting to the integral. That's enough. Now the next step is just you need to integrate first with respect to y, then with respect to x. I told you already. If you write y here, y takes constantly. That's also I will tell you. Just look at. We can write in this reverse order also. In this case, what happens? First we are going to calculate area between these two lines. If I write y is equal to 0 to y is equal to 1, what does it calculate? It calculates area between these two lines. But we don't want total area. I don't want the area from this left side. I don't want area from this. What is left side here? Left side is y is equal to x. You write x in terms of y. Reverse. Similarly, left side is over. What is right side? Right side is the area. What is x is equal to? Root y. What is x is equal to? Root y. This will be as it is. X minus 2y into dx dy. You can write in the reverse order. Both are equivalent. This is assignment for you people. You can go through this. I will solve this. First you can integrate with respect to y. You keep it x runs from 0 to 1 as it is. Integrate x with respect to y. What is the answer? Integration of x with respect to y. Can you anybody? X with respect to y. X is a constant. Take it outside. What is remaining? What is 1 with respect to y? Y only. xy. Integration of x is xy. Integration of 2y is I square by 2. 2 to get cancel again. Okay, between the limits x square to x into dx. Okay, now let us substitute. X runs from 0 to 1. Substitute y by x. X as it is, y is upper limit. Minus. Y is, okay, upper limit is over. Minus. Lower limit. X into y value is x square minus y value is x square whole square is into dx. 0. X square minus x square is 0. Minus x cube minus x raised to 4 into dx. Integral runs from, okay, now integrate with respect to x. X cube is x raised to 4 is between the limits 0 to 1. Okay, what is the answer? Upper limit. X is 1. 1 raised to 4 is 1 raised to 4 is 1. This is minus 1 by 4 plus 1 by 5. Lower limit is 0. 0 by 4 is 0. 0 by 5 is 0. It will become 0 plus 0. Okay, what is the LCM? 20 minus 5. 4 ones are 4. This is minus 1 by 20. So this is RHS. What is LHS? Minus 1 by 20. This is also minus 1 by 20. Green's theorem is verified. You can write once again. Integration of m dx plus n dy is equal to This is over a closed curve, this is over a region, dou n by dou x minus dou m by dou y into dx dy. That's it. Thank you.